Oh, hi, and good morning. Welcome, everyone, to Swoosh's webinar on technologies for PMI, which stands for Product and Manufacturing Information, which will be working together with MBD, or Model-Based Definition. I'm Dennis Streeter, one of the PLM consultants here at Swoosh. I'll be getting us kicked off this morning and come back to wrap up things at the end of the webinar today. Michael Pinto, one of our NX application engineers, will be covering our technical presentation on both PMI and MBD this morning. But before we get to that, I want to give everyone who's not familiar with Swoosh a little bit of an overview. Swoosh is a Siemens Platinum business partner, and we're headquartered in St. Louis, Missouri, while serving the entire U.S. nationwide. We focus our talents on three areas of Siemens portfolio: engineering, manufacturing, and the data and process management solutions. These three pillars cover a variety of solutions in each area that support strategies for both the digital twin as well as the digital thread. PMI and MBD are rather unique in that they could touch all three of these areas, depending on your company's processes, of course. We have specialists in each of these areas that consult, train, and support solutions we provide. And then we have a very unique approach to training in our industry by providing a process-based format to better transfer knowledge to our clients. So instead of marching you through a program's menu of systems and commands, we instead guide you through the commands and steps that you'll be using for completing specific tasks. Students tell us that this method effectively transfers knowledge while quickly improving their productivity in the new solutions once they get back to work at the office. That's a very brief introduction and overview of Swoosh. We welcome the opportunity to talk with you about your specific challenges and goals as well throughout the future. So before Michael gets started, I want to provide some background on these two manufacturing technologies. Sharing data among your company's departments has always existed. How that looks, though, has changed over time. From hand drawings to CAD drawings, prototypes to 3D models to animated 3D models or visual renderings. We continuously look for better ways to communicate our product designs for collaborating with others, both inside and outside of our company. Over the last 10 years, sharing product information and manufacturing information has become a hot topic. It goes back even further to 2003 when ASME included content in specification Y14.41 specifically for model-based definitions. 10 years later, the military started the transition to MBD by including it in their MIL standard 3100. So what were the driving factors that really resulted in these changes? For the military, they determined efficiency would be a huge driver. They looked at the amount of traditional paper documentation required for the various programs they're involved in that could be completed in a digital format that was more portable and searchable. And it didn't require killing a tree either. Better supply chain management, along with improving maintenance and repair capabilities, were just a few of those early benefits that MBD provided to the military. Michael will be providing more examples like this in his session. So while you get ready for the technical presentation, if you haven't already, I'd encourage you to jot down some areas that you think your company could improve by using or adding PMI data into your models. And then I'll be back at the end to provide some additional resources for you and wrap up today's webinar. With that, I'll pass it on to Michael. Michael, take it away.
Good afternoon, everybody. We'll go ahead and get started on our webinar here. First, we'll start out with an introduction. Again, my name is Michael Pinto. I'm an application engineer here with Swoosh Technologies, and I'll be presenting the webinar NX Model-Based Definition and PMI for you today. First, we'll go ahead and take a look at a little bit of a background on myself here. My name again is Michael Pinto. I am an application engineer and an instructor here at Swoosh Technologies. And a quick look at my background. I have over 24 years of experience designing products using these Siemens products. I started my career out in aerospace and transitioned into consumer goods, A couple of companies I have worked for in my career are Pratt & Whitney and Nike. I do enjoy teaching and supporting customers like yourself, whether that's in instructional in a classroom environment or virtually doing teaching for Swoosh here, also helping the customers with support related items with their Siemens products. My areas of expertise inside the software, as you can see there, are in the 3D modeling realm of NX. That is areas of advanced surfacing, freeform modeling, application of model-based definition, such as PMI on the parts, which is what we're here to talk about today, as well as assemblies, advanced assemblies, drafting, stage modeling, amongst many other modeling related topics. So a quick look at our agenda for the day. First, we'll be talking about what is model-based definition. Then we'll look at PMI capabilities, model-based definition capabilities. I'll go through a quick summary, and then we'll take a look at licensing requirements for the authoring of the model-based definition on your parts. So let's start off by talking about our first topic here. What is model-based definition? We'll be looking at the following topics, as you can see down below. So let's go ahead and get started. The first thing we'll look at here is an overview with this diagram, breaking down the definitions of PMI, model-based definition, and model-based enterprise. If you look at this diagram, you'll see a smaller circle there represents PMI. So the PMI is your product and manufacturing information. This is our non-geometric data that's being applied to the 3D model. It conveys information about the design of that product, and this information can be reutilized downstream in other operations. The next circle down, which is model-based definition. Model-based definition is the practice of producing a complete digital definition of your product within the 3D modeling application, and that includes the geometry, the PMI or product and manufacturing information, and the metadata with that digital file. And the largest circle here we're looking at is going to be the model-based enterprise. The model-based enterprise is the process of reusing model-based definition by downstream consumers across the enterprise. So when you look at this diagram, you can see PMI is created on the part. The PMI helps to define that part, which in turn is part of the model-based definition. That model-based definition can then be used downstream by other consumers of the data to get information about this digital model or your finished production part here. So what is model-based definition? Model-based definition is the information that is going to be embedded on the model to help communicate the design of that product. So that refers to PMI in this case. PMI is part of model-based definition. The PMI is the individual dimensions, the GD&T, 3D annotation, surface finish, material specifications, all of these pieces of information that help to define the product and communicate. So this allows the manufacturer and inspection of the product downstream without the need of 2D drawings. Now you can certainly still create 2D drawings here. And in our second PMI and model-based definition presentation that we do a little bit later on this year, we're going to show you how you can still create a 2D drawing workflow, but you can also use model-based definition to inherit that information into your drawings. So we'll be showing that in the second PMI presentation that we do a little bit later on this year. Now getting into model-based definition, NX PMI allows the digital data to be reused by parallel product development processes because the data lives and is driven by the product's parts. So essentially what we're talking about here is when you embed this information on the part, all this digital data is reading the physical geometry on that part. So what is the value in this? We can utilize this cost-effective and low-risk JT-enabled collaboration with the entire supply chain. And we'll talk about JT-enabled files when we get to a little bit later in the session here. We'll take a look at that. We can also leverage PMI to create accurate production-ready and fully associative detailed drawings. PMI-driven machining reduces NC programming time by 20%. So again, this is reusing the data from the physical geometry. We can take all the embedded information, we can pass that on to other operations in our company. If we look at the image there of the automobile door, you can see once we embed the information on the automobile door, this can be reutilized by these various processes here. We can designate work instructions, part planning and NC manufacturing operations, variation analysis we can do on that, assembly process planning, as well as CMM inspection programming. Now, We can also leverage a shared representation of the model-based product definition through model-based manufacturing. We can go ahead and take this information, we can embed it on a part, and the benefits of model-centric solution here are that we can reduce cycle time by avoiding data transfer, increase innovation through the ability to rapidly explore more design variations. We can also avoid redesign by validating manufacturing errors early in the development processes here. And master model enables production changes without disruption. Looking at the comprehensive digital twin is encompassing these three core categories here: product design digital twin, production digital twin, and performance digital twin. Your product design digital twin consists of the CAD and the simulation. The production digital twin is the process, plant, and human operations here. And then the performance digital twin is the IIoT, or the Industrial Internet of Things. Essentially the reuse of this data, being able to share that within the cloud, and having somebody grab this information very quickly to use inside their design process or their part of the job. If we look at the model-based definition and the digital twin, if we look over on the far left, the drawing-based design process consists of only a drawing. This was the way that we traditionally created parts back before CAD design. We would create that part on a drawing or a drafting board, make modifications. This was all 2D, hand-drawn work. If a change came back to the designer, he had to go right back in, erase a line, add a line, etc. Here, a lot of work was needed here to modify that design very quickly. Or I should say, not very quickly. If we look at the model-centric design process, that includes the drawing and the model, and the drawing being driven based on the model geometry here. Once we started creating CAD parts, we were able to take that CAD geometry and bring that into a drafting environment, add some views to our drawing sheet, and manually go in and create the dimensions to the edges of the part in those views. Jumping over to the next image to the right of that, the model-based definition type design workflow, we will be applying the PMI to the physical geometry. The PMI is going to be related to the physical elements and reading the digital model and getting all the information from the digital model. What's nice about this is we can then take that to the next image over to the far right and use that digital information, that PMI, model-based definition, within our model-based enterprise here and complete our downstream model reuse by reading the PMI and reusing that model-based definition in all of our other operations. If something changes in that digital model, the PMI updates, the model-based definition information updates, and then all of our downstream operations will update according to those changes. Getting into our next topic here, PMI capabilities. So we'll begin to take a look at these different capabilities in PMI, model-based enterprise, comprehensive 3D annotation tools inside the software, standards for that 3D annotation, take a look at some supplemental geometry options here. Also, how do we create lightweight section views inside of our designs and apply PMI, using the PMI in mirrored type situations, and finally talking about wavelinking and reuse of PMI inside of your designs. Whether that's the same part file and wavelinking that over to another part file and seeing what that looks like. All right, looking at the Siemens NX model-based definition portfolio, that does include the NX PMI and model-based definition, which will enable the production of a complete digital definition of your product within the 3D model, which is going to eliminate the need for your traditional drawings here. Next, we'll take a look at the different capabilities within the model-based definition application. That is going to be things like the PMI advisor, building rules, reuse of rules from a reuse library to quickly apply the PMI to your parts here. And then the PMI advisor is going to be utilized to check the PMI and the model-based definition against standards that you're using to design your parts to. All right, so looking at the annotation tools within the PMI toolset here, if you think of applying PMI as being very similar to creating a drawing or a traditional drafting practice here, you're going to have all the same tool sets, so we can create dimensions, annotations, specialized objects, security markings, supplemental geometry. We can create searches and reports. We can do sectioning and create lightweight section views of our parts to go ahead and detail the internals of the part. And we can also take advantage of a mirroring functionality as well within the design environment. And finally, we can wavelength PMI and reuse that PMI inside of other part files. Now, when we get into talking about the standards for your 3D annotation, there are two standards here we'll be talking about: ASME Y14.41, 3D Digital Product Definition Standards, and then we also have the ISO 16792, Digital Product Definition Data Practices Standard. So the software is using one of these two standards. Based on how you design your parts, what standard you use, you're going to go ahead and set that in the settings. And then when you're building your PMI or adding your PMI to your parts, we can run the PMI advisor, and it's going to check against one of these two standards and look at the PMI, how it's applied to your parts, and give you direct feedback whether that PMI is falling within compliance with one of these two standards here. So we'll take a look at the dimensioning and annotation inside of your PMI capabilities here. So this is a comprehensive dimensioning annotation capabilities that are going to allow you to fully define the geometry inside of your 3D environment here. So it's fast and easy to create this PMI on your parts. The tool set is going to be very familiar here. If you've ever gone into the drafting application, you're going to have the same tool set here to apply the PMI on the 3D model. We can reuse features and sketch dimensions, so I can go ahead and have a sketch inside of that 3D part. I can right click and I can go ahead and convert the sketch dimensions to PMI very quickly if I need to do that. So reuse of the feature and sketch dimensions is also going to save you time creating PMI on your parts. We can utilize multi-CAD data with PMI embedded JT. So if we go ahead and embed the PMI, we can share a JT file and send that out to somebody, and they can use the JT to go viewer and see the embedded PMI on the part that way. These embedded PMIs, they are going to be standards compliant, of course, based on one of the two digital standards that is chosen there to design your parts to. And we can capture, display, and consume these PMI objects inside of a tabular format as well. If you look at the ribbon bar there on the image, you can see that the tool set is going to be identical to the drafting tool set as if you were in the drafting application. Instead, we're in a 3D environment, but we have the same tool set available, and it's very easy to add the PMI to the parts using these tools. Jumping into the next topic here, we'll be looking at supplemental geometry. So as defined by your 3D annotation standards, supplemental geometry supports your model-based definition drawing list initiatives here. We can apply our PMI center lines and center marks, such as full and partial bolt circle center lines. Dynamic and interactive controls are available with those tools as well. So as you're applying these bolt circle center lines, you'll see a series of handles. You can interact with those handles very easily. Click on the handle and make an adjustment to the size of the center line at that location on the center line. Additionally, we can prescribe PMI regions, and we can designate an area for special purposes, such as limited application of a tolerance, area affected by a datum target, or maybe a specific area on your part that you want to go ahead and show somebody that in this specific area, we don't want paint applied to this surface. So these are PMI regions we can specify in our design and write on our physical surface and tell or communicate to another user a specific area of this part needs this requirement, or this is an area to keep a certain finish off of this part. These allow us to work quickly and efficiently while maintaining our standards compliance here within the standard that's chosen for designing our parts. We also have lightweight sections we can create. So the PMI sectioning is very easy to do. Go over to a PMI view in your part navigator, right click on that view, and then choose the view and create a lightweight section of that particular view. There are multiple section type options. We can create automatic crosshatch definition from the material that's already been applied to the part here. And this is standard compliant, and it uses a standard compliant cutting plane symbol as well. If you look over in the far right image there at the top, we do have a cutting plane. You can see the section cutting plane letters there with the arrows pointing to the cutting plane as we cut through this part. We can also mirror the PMI and model views as well here. We can reposition, delete, and we have some hide options as well. We also have the capability to wavelength PMI, and we can go ahead and reuse PMI downstream in other part files if we need to do that. Jumping into our demonstration here, we'll take a look at application of PMI on a part. All right, so here we have this part. We're going to jump into that part. And we're going to add a view set here. So the first thing we want to do is add a view set. We're going to give that a given name of PMI here. Once we apply our name, and we choose some views down below to add to our new PMI view set, these new view set views will be added to our part navigator, and you'll see that in the view set PMI there. In 1957, a new model-based definition navigator was introduced into the software. In this particular video, this is an older video, so we're using the part navigator. So the rapid dimensioning tool can be utilized here, and we can quickly apply some dimensions to our holes here. As you can see, it's reading the information about that physical hole, and we can apply tolerance to that just as easily as adding a dimension to a drawing here. In this case, we're using a 3D environment. Now we're going to apply a feature control frame. We can quickly add that to one of our hole callouts, and then add a datum feature symbol off of the feature control frame. Now, these three PMI elements have a direct relationship, and they go back to that hole. A section view can be created from one of your existing views. Right-click on the view, create lightweight section view. Go ahead and select that option there. And it's going to allow you to choose a cutting plane. We can specify the plane here to cut through that part, and then select OK. Now, once we cut through the part, we can easily apply some rapid definition or rapid PMI dimensions to the part. Picking these two edges here, we can apply this distance measurement, apply a tolerance, and now we can go ahead and associate some objects with that dimension. In this case, we're going to pick two faces to associate to this distance measurement. We're measuring between these two faces here. Once we pick the faces here, that's going to associate those faces with this PMI. We can easily place that now off to the right, and then begin creating our next dimension. And again, select associated objects here, the top and the bottom surface, and then apply that dimension and locate that inside our graphics environment here. Now we can apply some feature control frames. We'll apply a perpendicularity, add our tolerance to that. We'll go ahead and turn off our modifier here, and then we'll go ahead and apply that to the bottom edge of the part. We'll apply a datum here, representing datum C. Next, we'll export this part out in a JT file format, and you can see we can include the PMI with that JT file. Now, if we need to share these part files out with the vendor or customer, we can have them download the JT to go viewer, which is a free viewer provided by Siemens. They can open up the JT file format, and then they can go ahead and interact with that part very easily, and they can see all the embedded PMI on the part. As you can see, it's very interactive. If I click on that PMI note, it's going to highlight the surfaces associated to that PMI. Here's a quick look at our lightweight section view. Clicking on some of those dimensions, you can see the highlighted surfaces related to the selected PMI item. Next, we'll take a look at NX Model-Based Definition capabilities here. So we'll take a look at NX Model-Based Definition, some key features, automated PMI authoring on the parts, as well as the PMI advisor. So taking a look at some of the key features with our model-based definition, we can automate authoring of our PMI. We can also capture key characteristics and knowledge here. We can use the PMI advisor for validation and guidance, as well as direct consumption of the model-based data and downstream operations. And I do want to mention that this is patented technology, so Siemens does have patents on utilizing or embedding the PMI and model-based definition on the parts, especially when it comes to the automated authoring of the PMI on the parts here. So taking a look at the automated PMI authoring capabilities with PMI inside the software, this is a patented industry-first solution that's going to deliver significant productivity gains for repeatable and predictable processes inside your designs. The PMI authoring rules do more than speed up the authoring of the PMI. These rules also enable the user to capture more intelligence in the model, for example, default tolerance, lookup tables, associative patterns, counts, etc. here. Rules are not part specific and they can be reused across parts. NX does deliver 60 plus out of the box rules that can be used for production as well as to assist with learning how to author those rules. Next thing we'll look at here is what's called the advisor. The advisor is going to be a tool you can use inside the software here that's going to check the embedded PMI that you've placed on your design, how you've placed the PMI in relation to the features, and it's going to use those different standards. If you're using one of the two standards we talked about earlier in the session here, and you look at the PMI and apply that PMI to your parts, well, the software is checking in the background with the advisor here is going to look at the PMI applied to the features on the part. It's going to recognize if those features or the PMI applied to those features is out of compliance with the standard that you're using on your parts. This is going to ensure the production of higher quality parts in less time. It's going to provide guidance on corrective solutions and remove the dependency on highly trained GD&T experts. There are great helpers inside the advisor tool here. Even if you're new to GD&T operations and applying GD&T to your parts, there's some great guidance here with the advisor as well. You'll see pop-up interfaces, things like that, giving you additional information about maybe why something was flagged, a warning on those items, or something was flagged as an error. In addition, notification options include creating and editing and post-authoring workflows here. So not only can you use the out-of-the-box rules, you can also create and edit some of these workflows and build your own rules. This allows for a flexible configurable checking modes such as advising, enforcing, and we'll take a look at some of those settings when we go through the demonstration. And then this also supports multi-CAD validation requirements here. All right, so let's go through what the automated PMI authoring and PMI advisor process looks like here inside of NX. So here you can see we have a pretty complex part. It's got a lot of internal features here on the underside of the part. And we're going to go ahead and use some PMI rules to help us apply some PMI to these complex features. Now you can do this one of two ways. We can use the existing tools up here on our toolbar or our ribbon bar. As you can see over on the right, we also have a rule category that's going to include the capability to insert an instance or an existing rule here. Or we can go ahead and even define our own rules later on if we want to go ahead and do that. So you do have a define option here as well. You can use the out-of-the-box rules as a guide, and you can build upon those rules and create your own rules in the future. Additionally, once you create some favorite rules, you can add those very easily to the toolbar, and then you'll have easy access to take advantage of those rules right from the toolbar here. Now going over to the reuse library, we're going to take a look at some of the logical rules. This is where those PMI rules are going to be located in here. So we can go ahead and expand that. And inside of the folders here, you're going to see a couple of different options. We have automation, datum, dimensions, feature control frames, model views, notes, surface finishes, and technical data packages or TDP. So let's go into the datum folder here. Now we're going to add a datum. And the rule that we're going to use here is called datum across faces rule. And what we're going to do is we're going to be able to pick a single face. And with this particular rule, the software is going to look at that face and it's going to find all the coplanar faces with the chosen face and apply that datum to all the coplanar faces here. So as you can see, inside of our datum folder, we have a variety of different options, but we're going to choose the create across faces option here. Now, once you open up these logical rule dialogs, you're going to see there's a very familiar interface there. And the first thing we want to do here is select a face. So I'm going to pick a face here on the part. Apply our letter A here for our datum designator. Select OK. And then the software is going to go out. It's going to look at the chosen face here with this rule. And it's going to find all the coplanar faces with that face and designate all the coplanar faces as datum A. So after you select OK, you will see it's created our datum A on our part, and it's also found all the coplanar faces with that chosen face. So these are all representing datum A on our part now. If we had to do the same thing without a rule, you would have had to find all of those single faces or coplanar faces and pick those individually. So now we'll go ahead and move one of these faces here, and then we'll see if the model-based definition rule can be updated inside the part. So we'll select that face to move. We'll just use synchronous technology. Go ahead and grab that face and reposition that face, drag that down. We'll go back into our model-based definition navigator here. And you can see we do have a rules list. We have a create across faces rule. We can go back into the dependencies. You can see there's datum A. And we'll go ahead and right click on that and choose the update option here. So once that updates, it's going to go and reinterrogate the part, and it will be able to recognize that one of those faces has moved. So you'll notice previously moved face is no longer part of the coplanar group of faces, therefore it is no longer part of datum A. So we'll go back into our reuse library, and let's go back into another folder here. So we're going to the feature control frame folder, and we're going to choose the create position from datum feature control frame rule. So we can customize the settings for our feature control frame inside the dialog. These interfaces are very easy to use. As you can see here, we can go ahead and reduce or turn off our modifier here. Select our primary datum. And we can create a position from the datum rule. So what's going to happen here is it's going to interrogate the part. It's going to look at all the features on that part, and it's going to use some feature recognition to locate the features and apply the positional tolerances to those features. You can click on the PMI and reposition it very easily in the graphics display. And you'll also notice that the software found similar holes. So you'll see there's a 6X in this case in front of that feature control frame. So there are 6 features that are identical inside this part, and the software recognized that. Position from datum rule can be edited from the model-based definition navigator now. We can go ahead and modify the parameters here. So I'm going to modify the tolerance from 0.15 to 0.20, hit the enter key, and all those feature control frames will update. So you can see the benefits of using these rules on your parts and being able to quickly modify the information as well. In this example, we'll use the PMI advisor. It's going to help us validate the PMI that was created on our part. So I'm going to go here to menu, PMI, go down to advisor, and we'll go ahead and open up the advisor now in our software. The first thing we want to do is open up the configuration dialog though first. So we're going to go ahead and make some changes here in the configuration dialog box. You can see once that opens up, we have some actions. So this is the main dialog for managing the types of rules, and we can go ahead and tell the software what do we want related to the actions. So right now, checking mode is currently set to advise, or we can set that to enforce, or we can even turn that off. So advise, the software is going to go through, it's going to look at the applied PMI on the part. It's going to look against the different specifications that we're designing our part to, and it's going to advise us if there's something wrong. Now when you use enforce, what that does is it's not going to allow you to apply PMI to the part or that feature type that's outside of the active standard here. Now on the active standard dropdown, you'll see we have the ASME and the ISO standards, and we can choose the one that we are designing our part to. Over in the rules customizations, you can see all the different types of rules we have. And over on the right, once you select one of those rules, you can modify the settings related to that rule. Using the PMI Advisor configuration tool here, start to fine-tune how the software is going to be interrogating the part based on these different rules. All right, as you can see with the error checking, we can tell the software, when the feature control frame has no associated geometry, we can have it throw an error, give us a warning, or give us an informational indicator there on that feature control frame. So we'll go ahead and select OK. We're going to go back up to the datum feature symbol, and we're going to come back out, and we're going to go in and change the actual letter to I here. Now, anybody that's familiar with the standard drafting practice, you are not to use the letter I with your datums. So right away, we're getting an alert, and we can see the datum letter sequence contains an invalid character here. A datum label must contain at least one alphabetic uppercase letter. The letters I, O, Q are not acceptable here. So we'll place the datum I on the part and then run the advise check on the model. All right, so we've applied our datum Let's go back up to the Advise tool here. And we can open that up from the toolbar, as you can see with the icon. Now over in the HD3D tools, we can go ahead and run the advisor check on the part. This is going to run the advisor check. It's going to interrogate the PMI that's been applied to the part, and it's doing that against the standard that we're designing the part to. Now we can see there's a couple warning indicators here. We have a pass indicator, and we also have an X there for that datum that we applied a moment ago. Now, as you can see, as you place your cursor over the indicator, it's going to give you some information that pops up, give you some details about what that indicator is representing. Now, if we look at the datum here, you'll see the informational pop-ups. These are going to give some additional information regarding the error here. So we can see that that's failing based on the standard, and we can edit the datum feature to change the letter to B, so we're basically complying with the standard. So I'll set that to B, go ahead and close this, rerun the check, and then you will see, once I run this check again, it should give me a green check mark for my datum now. Now let's go ahead and fix the warnings on our position controls with the maximum material condition here. So we can go into the rules and remove the maximum material condition modifier on our frames. So we go back over to our model-based definition navigator, create position from datum rule, and we can go down into the details and we can go ahead and remove the modifier and set that to none. Now once we do that, it does take a moment to update all those feature control frames, but you will see the maximum material condition modifier drop off of the frames. Now we can run the advisor check one more time. Once we complete that check, you'll see that we have green check marks on all the feature control frame features now. All right, so that's going to conclude the demo there. Now let's take a look at a quick summary of what we talked about here. So in summary, the benefits of the PMI model-based definition applied to your parts. That's going to enhance and shorten the design and decision cycles being made on your parts. That's going to save you time. That's going to reduce costs here, especially in drawing preparation time using PMI-based models. Also, we can reduce scrap and rework by analyzing, optimizing, and validating products virtually before cutting metal. This is going to allow us to increase quality by optimizing the change management process here. So in summary, we have time, cost, and quality variables here that are going to be much improved based on the use of PMI and model-based definition on our parts. So taking a quick look at our lessons learned for successful deployment of a model-based definition strategy. We have 3 items here going from left to right. The first thing you want to do is build an adoption strategy. We want to develop a roadmap that aligns with business goals. When producing an implementation plan, include all departments who could potentially leverage MBD data here. And we also want to plan and budget education on working practices and technology for authors and consumers. This is a new tool you'd be introducing to your users. You definitely want to plan and budget for education on this. There is a learning curve here. Once you learn how to do this and apply this to your parts, though, you can see the great benefits. In the middle there, process evolution. We want to establish the model as the source of truth, develop working practices for both authors and consumers of model-based definition data, and consider how data flows between the different process steps. And finally, develop online, offline collaboration processes amongst your team members. And finally, for our risk management, don't underestimate the cultural impact and ensure benefits are clearly conveyed to all the team members. Also, run pilots with well understood use cases. Start out small here, start with a small project, implement some model-based definition and PMI on the part, and learn from that smaller project. And then develop and track productivity and your return on investment within the departments. Finally, anticipate investment and supplier adoption. Once you start to embed model-based definition PMI on your parts, if you want your customers or your vendors to be able to utilize that, you're also going to want to communicate with them. You're now embedding this PMI on your part, and we're going to start providing parts to you with this information on it. In turn, that can help them to improve their processes to become more efficient for maybe potentially manufacturing your parts, inspecting your parts, etc. there. All right, that's going to wrap up my portion of the presentation here. Once again, my name is Michael Pinto, and you have my contact information there on the screen if you want to do a quick screen grab of that QR code there That'll go ahead and save that for you. And you can always revisit the webinar at a later time as it will be posted and you'll have access on the Swoosh website. Up next, I'm going to hand it off to my colleague Dennis here, and he'll talk to you about licensing requirements to be able to author PMI on your parts.
Hey, thanks, Michael. That was a great introduction and overview of both solutions. We trust the time everyone spent with us today was insightful. I have some additional information that I can share with you here. You can use this as reference or share the information with others in your company as you discuss the benefits of PMI. If you have questions or want to do further research, you can also follow up with Michael by either email or phone, which are listed here. And then I've also included previous links that I shared at the start of the session today, along with a few other sites that you might find interesting as well. If you'd like a copy of those links emailed, my information is referenced here. And we'll see as well whether we can't get those put into the chat box so you can copy them down if you prefer. If you'd like to review or share this webinar, we'll be posting an archive on our website. Once you're on our website, just go to the top banner and look for the resources and events section. And in that pull down, you'll find all of the archives listed as another option. Now let's wrap up with a short observation about these technologies. Then I'll end with details on the pricing options for those of you that want to pursue these solutions further. As I mentioned at the start, MBD has been around now for some time, and this graphic kind of provides a history of that development over the years. And over the years as well, I've worked with a lot of small to mid-sized manufacturers, most of them well past that drawing-centric group that you'll see shown in the graph above, and being fully engaged in the model-centric world. Still, many of them felt that MBD was for those larger, higher production or more complex product manufacturers. And while that's true, there are still many benefits for the SMB manufacturing community as well. Maybe your company has an initiative to make a digital transformation, and that's why you're attending today. Or perhaps your company isn't ready to take that step to the digital environment quite yet. If that's where you're at, you can still use PMI and MBD to create traditional paper documentation while providing you the technology to start exploring and mapping out your digital strategy. Using PMI data can open the door to providing a more complete manufacturing package for other departments in your company, improving their efficiency as well, while improving the quality of the parts and the products that you build. It also shows your larger customers that you're ready to support their business and the digital transformation strategies that they're invoking. So now on to licensing. This is the first of two slides to cover both your authoring as well as your consumer licensing options. PMI is now a core content inside of the NX CAD, both Mach 2 and Mach 3 bundles, while MBD is an add-on for either of the Mach 2 or Mach 3 licenses. I've included the product numbers for all those solutions here as part of your reference material to take away. This slide lists ways that consumers of product and manufacturing information can access that information added to your models. Some consumers, like CAD for manufacturing data or CAM for CNC programming or inspection solutions, may also be adding content that's relevant for their department, in which case the solutions they're using will view the model's PMI data while they add their own data as well. And if you're using solutions outside of the Siemens Eco, you can contact us to review the options you have for those areas. And I'll note that all the Siemens solutions are very open to other solutions while still supporting your viewing for PMI data using standards like JT, Adobe Acrobat, or STEP. Last of all, I want to thank everybody as we wind down here. Your time's valuable and we appreciate you spending it with us. We enjoyed sharing today's PMI and MBD information with everyone. And until our next session, all the best designing and manufacturing great parts and products. And don't forget part 2 that's coming up here as well.